The aims of this guidance are firstly to bring greater coherence to the national curriculum by exposing core concepts and demonstrating how they progress from year 1 to year 6, and secondly to summarise the most important knowledge and understanding within each year group and important connections between them. This video guide summarises the knowledge and understanding that year 1 pupils need to achieve by the end of the year in order to be ready to progress to year 2. There are accompanying materials which provide teaching guidance for each ready to progress criterion and example assessment questions. In year 1, pupils should learn to count to 100 and recite the number names fluently, both forwards and backwards. Pupils should be supported by different representations, such as a 100 square, which draws attention to patterns in the number system by grouping the numbers in rows of 10. Be aware of typical difficulties and support children with these, for example, using a number line to help children know the next 10, so 58, 59, 60. Emphasise multiples of 10 in your own counting so children learn to differentiate these from teens numbers, so 40 rather than 14, and show one less than a multiple of 10 to support counting backwards, for example. Pupils should also count supported with cardinal images and the process of grouping into tens. It's important that pupils experience this using both real objects as well as images. 47, 48, 49, 50. A useful activity is to keep track of the number of school days throughout the year by adding a straw to a chart each day and grouping into tens as the days build. Pupils should become familiar with seeing 0 to 20 number lines and placing the numbers 0 to 20 in the linear number system. They should be able to identify numbers on partially labelled number lines like this one using strategies other than counting forward in ones. For example, identifying that this number is 5 because it sits halfway between 0 and 10, or that this number here is 19 because it is 1 less than 20. Pupils should also be taught to estimate the position of numbers to 20 on an unmarked 0 to 20 number line. Teach children to mark the midpoint of 10 to help do this. For example, 16 sits roughly here relative to 10 and 20. Positioning numbers in the number system like this prepares children for working with scales on measuring instruments and charts, for example, measuring the length of this leaf, and helps children compare numbers and make estimations, for example, estimating the length of this rubber relative to a 10 centimetre length. Pupils need to be able to add and subtract within 10 fluently by the end of year 1. This should be taught and practiced until pupils move beyond counting forwards or backwards in ones to more efficient strategies and automatic recall of these number facts. This prepares pupils for the 2-digit additive calculations they will meet in year 2. Pupils should memorise some facts such as number bonds to 10 and doubles, and also be taught to derive additive facts within 10 from previously memorised facts. For example, 3 plus 3 is equal to 6. So 4 plus 3 must be equal to 7 because it is one more. Pupils must be able to count in multiples of 2, multiples of 5, and multiples of 10 by the end of year 1 so that they're ready to progress to multiplication involving groups of 2, 5 and 10 in year 2. When pupils are confident reciting the counting sequences, they should learn to enumerate objects arranged in groups of 2, 5 or 10 by skip counting. Pupils should practice counting in 2 ways. So first of all, just counting the total number of objects using skip counting, 10, 20, 30, 40 and so on, or counting the number of repeated groups like this: 1 10, 2 10s, 3 10s, 4 10s and so on. Associating 40 with 4 10s, for example, will prepare pupils for multiplication and division in year 2. Pupils should also learn to recite the odd number sequence both forwards and backwards, and this can initially be supported by a number line with odd numbers highlighted. Before pupils start formal addition and subtraction using written notation, pupils should be given experience of composing quantities to 10 from 2 parts, like this: the basis of addition and partitioning quantities to 10 into two parts, like this, the basis of subtraction. Pupils should learn to interpret and sketch partitioning diagrams to represent the ways numbers can be composed and decomposed, and they should use the language of whole and parts and describe the relationship between them. Pupils should learn how to work systematically to partition each of the numbers to 10 into two parts and should recognise there's a finite number of ways that a given number can be partitioned. Pupils must then be taught to use the mathematical symbols for add, subtract, and is equal to. Expressions or equations involving these symbols should be introduced as a way to represent numerical situations rather than as an instruction to calculate. For example, here we can see that there are 5 cakes, 2 have cherries on and 3 don't have cherries on. And we can write this as 2 plus 3 is equal to 5. The 2 represents the number of cakes with cherries on. The 3 represents the number of cakes without cherries, and the 5 represents the total number of cakes. Examples should use quantities within 10, and they should be supported by manipulatives or images so that pupils' focus is on the mathematical structure. Pupils should also describe situations involving a change over time. First, there were 4 people on the bus, then 3 more people got on. Now there are 7 people on the bus. And pupils should learn how to represent situations like these with equations. The 4 represents the number of people on the bus at first. The +3 represents the number of people getting on the bus. And the 7 represents the number of people on the bus now. 4 plus 3 is equal to 7. Pupils should also describe situations involving reduction. First, there were 4 children in the bumper car. Then 1 child got out. Now there are 3 children in the bumper car. And they should also learn to represent these with equations. The 4 represents the number of children in the bumper car at first. The -1 represents 1 child getting out of the bumper car. And the 3 represents the number of people in the bumper car now. 4 minus 1 is equal to 3. So by the time they finish year 1, pupils should be able to write and interpret equations corresponding to the additive structures of aggregation and partitioning and augmentation and reduction. In geometry, pupils need experience in handling and discussing common 2D and 3D shapes. In the process, they'll learn to recognise and name common shapes such as these cylinders. Pupils need to be able to recognise shapes presented in a variety of orientations and sizes and relative proportions, including large shapes outside the classroom. Pupils should be able to describe the differences between non-similar examples of the same shapes using informal language. For example, talking about a long and thin cylinder or a short fat one, but recognising that they're both cylinders. And just as pupils learn to compose and decompose numbers in year 1, they must compose and decompose shapes, for example, arranging shapes to match a 2-dimensional image of a compound shape. And pupils must be able to rotate pieces to lay over an example image, like these pattern blocks here. And by the end of year 1, pupils should be able to copy shape arrangements without overlaying pieces on the example. And this ability to compose and decompose shapes and see shapes within shapes is a skill pupils will need through to Key Stage 3 and Key Stage 4 and beyond. Pupils should also compose and decompose 3-dimensional shapes, for example, investigating what compound shapes can be made from 5 linking cubes. Pupils should be able to rotate and turn shapes to help compare them, such as comparing these 2 shapes here and discussing whether they're the same or different.